Hello everybody, good to see you, and welcome to Ask Math Anything. As you know, what we do in this session is we have people come in with whatever questions that they might have about math, and then they can ask anything. If you have been here before, then you're used to that. If you haven't been here before, welcome, and I hope that you have some interesting questions that you're curious about. I wonder what we should start with today. Actually, I can tell you what I should start with today. Looks awfully bright on this side. That's because we just adjusted some of the lighting in our studio. Let me just adjust that down. One moment, please. Okay, hopefully this is a little bit better. Great. So what kind of questions should we ask? Oh yes, I see that people are interested in bananas, or rather maybe the color of my shirt, which appears to be a banana color. I'm actually also adjusting this so I can read what you're writing a little bit better. And I see that there's some questions already. Oh, okay, let's try this. Somebody has asked, suppose that you have two numbers, and suppose that the product of two numbers is minus 16. And this is a question from Daksh Gupta. You ask a lot of these questions. So Daksh Gupta asks, suppose I have two numbers, and their product is minus 16. And Daksh Gupta asks, what is the smallest possible sum of the squares of the two numbers? Smallest possible sum, oh that's not how you spell possible, smallest possible sum of the two numbers. How can we do this? Oh, I have a bunch of interesting ways I want to do this. So what do you think about when you see something like this? Yes, importantly, these numbers can be negative. So for example, if I have x and y, well actually it's probably not possible for x and y to both be positive, right? Because if you take plus times plus, you get plus. So actually I have two numbers that multiply together to make a negative number, so one is positive, one's negative. Well, here's something else that you can do to be a little bit easier. What you can also do is you can say, hey, let's just do the problem where their product is plus 16. Because the only difference between this answer and the other answer would be that I take one of my numbers and make it negative, right? If I had 4 and minus 4, I could do 4 and plus 4 to be over here. And the sum of the squares, when you're squaring a number, changing its plus and minus doesn't make a difference. I see there are lots of people here who think that the answer is 32, which is what I would get if I did 4 times 4 over here. And then over here, I'll get 4 squared plus 4 squared, which is 32. 16 plus 16 is 32. So that feels like that might be the right answer. But is there a way to explain why? I wonder if anyone has a way that they could use to explain why the answer is what it is. How could we think of this? I'm going to say that there's a way to do this with an inequality, but there's also a way to explain this with geometry. And I'm going to try this, okay? You're basically saying, if I have two numbers and I multiply them together, what's the smallest possible sum of squares that you can have? There's another way I can flip this question around. I see some people wrote AMGM. AMGM is an inequality that people often learn for high school math contest problems, and that is the correct answer. But here's something else that you can use. You don't need to use high school geometry. Well, maybe it's sort of geometry. Does x squared plus y squared make you think of anything? If you ever see x squared plus y squared, does that ever make you think of anything that you might do in geometry? A circle? Yes, a circle is useful. Right, a circle is definitely something that this might be in. Is that something I could say? Yeah, sort of, but it's also a hypotenuse of a triangle. Let me flip it around the other way. What if I said, a different problem, x squared plus y squared is equal to 1? What if I ask for the biggest xy? I claim that these two problems have a very similar flavor. What I mean by this is, if you're trying to find an x and a y, oh wait, maybe we should say what this looks like. If I have an x and a y, it's like the Pythagorean theorem, right? It's like I have x and y. Can anyone help me interpret what xy might mean? Can anyone help me interpret? Xy means the area of the rectangle, right? Xy is the area. Area equals 16. And if I'm asking about the x squared plus y squared and trying to make it the smallest possible, I could also say, what's the smallest possible square of the hypotenuse? Let's do this. But if I want to find the smallest possible square of the hypotenuse, that's the same as finding the smallest possible hypotenuse and then squaring it. Smallest diagonal. So now I have an interesting geometry problem. Suppose that somebody just gave you, a rectangle, and the rectangle had a certain area. How do you choose that rectangle so that the diagonal is as small as possible? Well, that sort of makes sense that the answer should be a square, right? This is saying, like, if I fixed my area and I want a small diagonal, how do you do it? Probably a square. Well, I can be even more specific. Let me flip over here. This one asks the question just turned on its head. This question is saying, I've got my rectangle. And what this is saying is that suppose that I'm given that the diagonal is something, 1, and I'm asking for the biggest area. I claim that the shape that works for this is the same as the shape that works for this. Because if my goal is, with a certain stuck area, make the smallest possible diagonal, that will be the same shape that, with that particular diagonal, gets the biggest area. Does that make sense to people? I'm just showing you that these two are the same kind of question. But this one is easy to answer. If somebody told you the diagonal of this rectangle and said, get me a big area, that's easy. Watch. Well, not necessarily easy. But if I tell you, hey, here's my diagonal. I'm writing the diagonal horizontally. If that's my diagonal, and I want to go and find the way to make that a diagonal of a rectangle with the biggest possible area, here's the trick. Did you know that if I take a circle and use that as the diameter, something interesting happens? Sort of a lumpy circle, but I hope you get the idea. This is just a circle that's going around, okay? Now, if that happens to be the diagonal of a rectangle, now there's something nice about what happens if you try to make a rectangle with that diameter. Does anyone know what's going to happen if I take any point on that rectangle and how it compares to the circle? Suppose I try to make a rectangle with this as a diagonal. Do you know what will happen to my other points which are on the rectangle? This is a really important point. If you try to make a rectangle, they will all be actually on the circle itself. So every rectangle that you could make looks like this. There's a fact from geometry that if I go and take any point on that circle, it makes a right angle. And in particular, every right angle gives me a point that's up there. So now, if I wanted to know what it looks like to go and try to make a rectangle with some area, hey, here's a question. If the way I'm going to make my rectangle is I'm going to choose one point there and one point there, which points should I choose to give me the biggest possible area? Well, here, I can use something called half base times height. I'm actually showing how we're actually doing AM-GM inequality. That's what we're really doing. But I'm showing it to you through a geometry problem. If I wanted to go and make this have the biggest possible area, the area of the top part is half of the base times the height. So how do you make the biggest possible height? By going all the way to the top. The biggest possible height would actually be made by not doing what I had drawn, but by taking something all the way on top and connecting it. This is the biggest possible height. Right? Because that's just like going all the way straight up. And then what that means is if I went and tried to do this, then the way I would get my biggest possible rectangle would actually be a square. And this actually shows you how, if your problem was, I have a diagonal and a rectangle of a certain length, what rectangle has the biggest area, it should actually go all the way up and all the way down, making a perfect square. And so that explains why the answer to this whole problem is actually the 32, which we had before. All right, so that was fun. We had the chance to talk about a problem that looks like algebra, and then move over to geometry to think about it. Meanwhile, I still think it's a little bit bright on this side. Still trying to figure out why. So what I'm going to do is I'm going to try to block off some more of the light. Ah, that did it. Okay, now I got to do it from the other side too. 1 second. Okay, now it looks much more reasonable. The way that light works, oh, you can't see any change. It's because maybe you're not used to staring at the effects of the light all day. But what happened was that there was some extra light on each of these sides, and that has been adjusted. Okay, great. Let's do some more questions. Oh, okay. I wonder if this one is reasonable. We'll find out soon. This problem is from Mithun Goswami. And Mithun Goswami says, let x be a number less than 100. So x is a number less than 100. What do you want me to do with x? Oh, the square of x has its tens digit odd. X squared, tens digit, is odd. Okay, and the question is, what is the units digit of the square of x? Is this possible? I'm a little bit not sure if this is possible. You're saying, what is the units digit of the square of x? I'm a little concerned that there's going to be a lot of different answers. So, indeed, 6 is one of these that I could do, because I see that 16 works. Right? I could do 16 works. But I assume I could do more too. Oh, I could do 36. X squared equals 36 works. Okay. What's next? 49, 64. Am I missing any squares? Okay, 1 for 9, 16, 25, 36, 49, 64, 81, 100, 121, that's 11 squared, 12 squared is 144, 13 squared is 169. Wait a second. How come all these tens digits are even? 13 squared, 14 squared is 196. What? It works? Okay. Okay, it says x less than 100. So I actually thought that the problem would have lots of answers. But it appears that so far I have gotten 6 a lot. And what's next? So that's 14 squared, 15 squared is 225, not interesting. 16 squared is 256. Whoa! Okay, I like this question. This is interesting. Okay. So it looks like the answer is 6. Why? Let's figure out why. Okay, so now if I have to think about this, let's go and break apart x. X is less than 100, so x is a tens digit and a units digit. By the way, maybe the tens digit is 0. We'll allow for that. So if we're going to say that x is the tens digit plus the units digit, x is equal to 10 times t plus u. Okay? So that's how you would write any one of these 2-digit numbers. Now let's go and square it. The way you square this is you can multiply 10t plus u times 10t plus u. And if you actually went through the trouble of expanding this, you get 100t squared. That's the two first things multiplied together. I'll also get a 10tu and another 10tu. That's 20u. No, 20tu. Oh no. Oh, what a funny tongue twister. Yes, you know, this was 10tu. That's correct. It was 10tu. But then it becomes 20tu, not 20u. Okay. Plus 20tu plus a u squared. Okay, plus u squared. All right. Now, this thing is telling me that what I need to do is I need to think about what happens if the tens digit. Yeah, I see that somebody is asking, like, how much is 10t? I'm not sure. 10t. A 10t should be 100, shouldn't it? Anyway, yes, 20tu. Oh my gosh, how do you say that? Anyway, so we got this u squared plus this plus this. Oh, but look at that. If you know that the tens digit is odd, is this going to change the tens digit at all? This doesn't affect the tens digit at all because it's 100 times something. So that has no effect on the tens digit. So this thing, no effect. on the tens digit. Okay, that's true. But look at this one, 20 TU. Okay, well, since there's a 0 here, that means that this contributes 2 TU to the tens digit. But there's a 2 here. Since there's a 2 here, this contributes an even amount to the tens digit. And since I said that since the question by Mithun Goswami says that the tens digit is odd, this 20 TU doesn't affect the evenness or the oddness of the tens digit because it's a 20 TU. Okay? So over here, this thing here has no effect on the parity. Let's call it the even or odd. Even/oddness of the tens digit. Okay, so that's because it's 20 times TU. It has a 2. It's just like if I have a number and I go and add 8 to it. It will still be the same evenness or oddness as it was before. So now we go to the U squared. So now we say, all right, that's the only thing that's going to affect the evenness or the oddness of the tens digit. So now let's just go and see, what could U be? U is a units digit. So if it's a units digit, let's just go and make a chart. Okay, so the way I'll make my chart is by drawing a line that's a little bit more vertical. Sort of, a little bit more vertical. Let's go and make a chart of what happens to the units digit squared. And let's see which units digits give me an odd tens digit. So I guess I should go and make a table somehow. Let's do it this way. U squared. And let's go and look at them. And let's go and see which of them give me an odd tens digit. The units digit could be 0, but that gives me 0. That's not interesting. 1, 1, we just do it, okay? 2, 4, so far these are not odd units digits. Odd tens digits. 3, 9, not interesting. Oh, but 4 comes in. Let's use a different color because it's exciting. This is 4 and 16 because that 1 is odd. So that happens to give me something where the units digit, the tens digit is odd. 5 is not interesting because the tens digit is even. 6, ooh, 6 is good. 6 gives me 36 and 3 is odd, so that's why that's unusual. But 7 gives me 49, which is an even tens digit. 8 gives me 64, even tens digit. And finally 9 gives me 81, even tens digit, and I just made it without running out of space. But if you look at this, then there's only 2 choices for U, which could possibly give me a tens digit odd. The only way is if U is equal to 4 or 6. But in both of those cases, I get a 6 for the units digit. So the answer is 6. Amazing! Okay, I learned something today. When you asked me this question, I just was like, oh, come on. When you asked me this question, I was like, come on, your question is bogus. There's got to be more than one answer because there are so many squares and it's got to be easy to have the tens digit odd. That's what I thought. And so I said, you probably got the wrong question. I'm going to show you that you're wrong. And then I found out I was wrong. By the way, you can also change this question a bit. Do we really need that x is less than 100? Do we? I don't think so. I think all we need is that x... Oh, and we're talking about perfect squares. I think you can use any integer x that you want. If x was minus 5,207,000, if you square it, it's positive 5,207,000. And by the way, this t, if the t is not a one-digit number, everything here is still okay. You can always write down that x equals 10t plus u. If the number was like 256, well, that would be, if x was 256, t could be 25 and u could be 6. It's okay, right? So what we see here is that, in fact, we didn't even need to have the x less than 100. Let's go and get rid of that. And instead, we have this really interesting fact. Wow, I like it. Thanks for the question. I'm going to adjust the light a little bit more. I just realized that this side of my face comes from there. I mean, to you guys, it's like it's obvious. I mean, come on, it's this side of the face. Of course it comes from there. Except that the thing that's hard is that in my screen that I'm looking at, everything is mirrored. So that's why I went there, thinking that this side of my face was there, because it was mirrored. And then I adjusted the wrong light. Let me adjust this light down. Okay, hopefully this is a bit better. More questions. DA asks, if you hit your face really hard and it hurts really bad, are you strong or weak? This is a deep question. I don't know. I think that if you hit your face really hard and it hurts really bad, here's what I'll say. I'm not sure if you're strong or if you're weak. I'll say that you made a mistake, and please do not try this at home. John Vick asks, can you please tell me argument or modulus? I think you're talking about complex numbers, which is when you have a number which has this square root of -1 involved in it, like 3 plus 2i. Both of those are different things. The modulus is like how long it is, how big the complex number is in some sense, the magnitude. And the argument is like what angle it tilts. But those are different things. So I wouldn't choose one over the other. But we won't go deeper because that's beyond the scope of what we usually talk about here. That was about complex numbers. More questions. Vera Wang, is your shirt made of bananas? No, I don't think so. Doesn't seem like it. Doesn't smell like it. More questions. Let's try this one. It's about a triangle, okay? So I don't know where these questions are coming from, but they seem like they're letting us talk about lots of different topics, which is fun. Joshua Wu has given us a triangle. And this triangle is it's a legit triangle. And the triangle has sides of length x, x plus 4, and 3x minus 5. And the question doesn't say find x, because there are lots of different answers. But the question was, what is the possible range of values of x? Okay, so now the main question is like, well, I mean, can't you just choose anything? For example, if I just made x anything I want, like a million. Whenever you're in doubt, choose a million, okay? Like if x is a million, I've got like a totally legit triangle, right? I can just go make a triangle, look at my triangle, x is a million. I should have chosen a smaller number, but it's okay. A million. And a million and 4. And, oh no, what's that? 3 million and minus 5. But we're not allowed to do that. So I guess that is 2,999,995. Don't you agree that this is a totally legit triangle? Well, there's a little bit of a problem with this triangle. If you go and try to make this triangle, you will start here with a very long stick of 2,999,995, and then you'll make another stick that's this long and another stick that's that long, and they won't touch. Like they're not long enough, because this 1 million plus the 1,000,004 is not big enough. It doesn't match this. So it's bad. It's bad. Like this thing goes out a little bit, this one goes out a little bit, and they don't touch. No triangle. Do not try this at home. That's not a triangle. So this is called the triangle inequality. The triangle inequality says that no matter what, the lengths of the two bits need to be at least long enough to get you all the distance here. Another way of saying this is that, did you ever hear before that the shortest path between 2 points is the straight line, right? So now I happen to know there's one important inequality, which is that the x plus the x plus 4, that has to be at least as big as the 3x minus 5. Okay, so here are some things that I would need. I need that x plus the x plus 4 is at least the 3x minus 5. But that's not the only thing I need. I also need to make sure that it works for all the others. I need to make sure that the x plus the 3x minus 5 is at least the x plus 4. I mean, I don't know. In some cases, 3x minus 5 could be small because, you see, there's a minus 5. Who knows? Maybe it could be. I'm not sure. So let's find out. So I also need that x plus 3x minus 5 is bigger or equal x plus 4. And x plus 3x minus 5 needs to be bigger or equal x plus 4. Now I also need that x plus 4 plus 3x minus 5 is at least x. But the reason why I know that one has to be true is because if the x plus this thing was at least x plus 4, then it's even easier for x plus 4 plus this thing to be at least only x. So that's why I'm saying that I just need these two things to be true, and then I can make my triangle. Then whenever I put down put down one stick, the other two sticks will go and make me a triangle, as opposed to waving unable to touch. Okay, so I need these both to be true. Well, let's go and find out what they tell me. What's the first one going to tell me about x? I guess I'll use yellow. Let me erase the thing that you should not try at home. For the yellow, x plus 4 bigger or equal 3x minus 5. That is 2x plus 4 bigger or equal 3x minus 5, and that is x less than or equal to 9. So now I know I better make sure my x is less than or equal to 9. Oh, and that's how you can also see that I better have another inequality. Because if someone told you, hey, just pick any x that's less than or equal to 9. Well, there's another problem. The other problem is, how about negative sides? Ooh, actually I have to put more stuff. I can't have negative sides. I also need that the sides are all bigger or equal to 0. Let's go and add some more conditions. X has to be bigger or equal to 0. And, one more, 3x minus 5 has also got to be bigger or equal to 0. Let's get more space. 3x minus 5 needs to be bigger or equal to 0. The reason that all these are necessary is because I do need that I have positive things. Not bigger or equal. Bigger than 0. Bigger than 0. Oh, you know what? Actually, all of these should have been strictly bigger than. Because we have a triangle. If you want a triangle, you actually need that you're not like stuck like a line, right? If you had the length of one side plus the length of the other side equals the third side, that's not much of a triangle. That's one line and like rubber band stuck down. Awful triangle. So I need all of these to be strictly bigger than 0. So now I've got this. Let's go and look at the rest of them. The green one tells me that my condition is x plus 3x minus 5 bigger than x plus 4. Let's subtract x from both sides. Those x's are gone. And I just get 3x bigger than 9. So I find out that x had better be bigger than 1/3. Oh, that's interesting. X has to be bigger than 1/3. By the way, I hope that you guys are helping pay attention, because this is not the answer I saw typed into the chat earlier. So I'm wondering if there's a mistake. Maybe I made a mistake. But it looks okay. 3x bigger than 9. Oh yeah, wait, I can't divide. No. 9 divided by 3? 3. Okay, 3. Okay, yes, good. So that's 3. Good thing that people are paying attention. The next thing is, I need to make sure x is bigger than 0. Oh, but it will be, because x is already bigger than 3. So it's already going to be bigger than 0. That's nice. How about the 3x minus 5 bigger than 0? Let's double check that. 3x minus 5 bigger than 0 tells me that x is bigger than 5/3. I just added 5 to both sides and then divided by 3. But if I look at this, the x bigger than 5/3, this x bigger than 3 is a stronger condition. So that means that these two are the only conditions that actually matter. So it tells me that the possible range of values for x, let's do a box in a different way. So that tells me that the possible range of values for x is x goes between 3 and 9. Why did I box that? I think I would rather box the answer. X goes between 3 and 9. And I hope that's the answer. If that's the wrong answer, please help correct me. But it feels reasonable. And if I look at this, here's what I'll do. I'll say, hey, let me check the endpoints. What if x was 3? If x was 3, 3x minus 5 is 9 minus 5, which is 4. Okay, 4. And if I had 4 here, and 3 here, and 7 there, oh yeah, that makes like this thing all into a line. Great. So that's why 3 is one of the endpoints that we don't allow. 9, on the other hand, I would get 3 times 9 is 27. 27 minus 5 is 22. Wait, what happened? Something is fishy. 3 times 9 is 27. I think I made a mistake. What's going on here? Did I make a mistake? Oh, maybe it's okay. Oh, it's okay. It's okay. I didn't make a mistake. It's okay. So 3 times 9 is 27. 27 minus 5 is 22. I was just like, 22 is so big. How can I get 22? Oh, I can get 22 with a 9 plus a 13. That's 22. So that would make like one big old line right here. So I think this is the answer. And if you ask the question, please let me know if this matches the answer you were expecting. Unless you were actually just giving me your math homework, in which case I hope that this matches. Yeah, apparently we have learned that some people come to Ask Math Anything to be like basically do my homework for me channel. Well, anyway, at least we get to find the kinds of homework that people all over the world are trying to do. While that helicopter is going by, let's go choose another question. Ooh, a puzzle. Let's try this. It's a number puzzle by Jacob Flint. Jacob Flint says ABC is 10. I think you mean multiplied together. And you also said that A minus B minus C is equal to 10. And you said that A is bigger than B. B is bigger than C. And you want to know what is A, B, and C. Okay, the question is what is A, what is B, and what is C. Is it possible? At first I was going to be like, oh, this should be easy. Let's just go and figure out how to factor this thing. 10. 10 is just like 5 times 2 times 1. Oh no, it doesn't work. Okay, fine, I'll be more clever. 10 is 10 times 1 times 1. Oh no, it doesn't work either. What? Now we need to go and figure out something that actually does work. Well, let's see. Oh, neat. I just saw that there's somebody in the chat who said that, hey, you can actually do this. You see, I was going to say, I think there's a lot of answers. The reason why there's a lot of answers is because I only have 2 equations and I have 3 unknowns. And if that was the case, there could be lots of different choices for the answer. How might I try to actually do this? Well, because the equations are not nice, one is like all 3 multiplied together and one is here. I see that some people are saying you could potentially use decimals. Here's what I would do. I know that the answer has come already, but what I would do is I'll just do substitution because the second equation is nice for substitution. The second equation, and of course guess and check here does work pretty well because you just factorize 10, and if you use negative numbers you'll get something. But here I'll say that A equals 10 plus B plus C. I basically want to talk through what you would do if you had numbers that you couldn't guess and check. Because somebody could have given you a problem where the numbers aren't nice. So if A is 10 plus B plus C, let's put it back up there now. So when we put it up there, we get 10 plus B plus C times B times C equals 10. Now how would you solve this? Well, I'm going to turn the B and C into like, well, let's turn one of them into an X, okay? That'll make it easier what I'm about to do. That'll make it easier to see what I'm about to do. Let's solve for B. Call it X. Now what I have is I have an equation that says 10 plus X. I don't know what B is, so I'm calling it X, plus C. Now I'm going to say I want to solve this for every possible value of C. Times X times C is equal to 10. Hey, it's a quadratic equation. if I went and expanded out this piece over here, I would get a cx squared plus, how much x's? It looks like it is c squared plus 10c x's minus 10 is equal to 0. Let me take a step back. Is that right? So what I've just done here is I've said I have a c squared, that's right, cx squared, that's that part. And then I also have how much times the x? Well, I have a c squared plus a 10c. So that's how much x there is, a minus 10. What I'm showing you is that but there's a whole lot of different choices for c that you can throw in here and get an answer for x. X is b. So now I get the quadratic formula. X equals minus the second coefficient, minus c squared minus 10c, plus or minus the square root of something disgusting. C squared plus 10c squared, that's b squared, minus, which becomes plus, 40c all over 2c. What I just showed you is a messy, messy formula. Disgusting. But for any c that you choose, as long as the inside is positive, which actually is going to happen for all positive c's, for example, if I chose c to be like pi, I'll get something. I could put c equals to pi in here, and I'll just get something. I'll take the square root of it, and that'll give me a choice for b. So what this is showing that there's actually infinitely many different solutions. You can choose lots and lots of different things to be your c. But now if you wanted to say the answer has to be integers, then at that point you go into what people have done, which is to go and prime factorize the 10, and I see that as soon as you use negative numbers, you're good. And I saw people have something with something like, what was it? 10 minus 1 and minus 1? No, that didn't work. How about minus 10, 1 and minus 1? Does that actually work? If I had 1, minus 1, and minus 10. Yes, that should... Wait, does that work? Wait a second. Now I'm a little bit curious. Does this actually work? So if I have 1, minus 1, and minus 10, they do multiply to 10. I'm happy with that. But if I try to have the biggest one minus each of those, don't I get 12? Wait a second. Now I want to double check. So somebody said that A is 1, B is negative 1, and C is negative 10. Are you sure? I don't think that works, because 1 minus minus 1 minus minus 10 is actually going to give you 12. So this is actually, that's not so good. So it actually looks like, you said minus 1, 1, and 10. Does that work? If I do minus 1, and then 1, and then minus 10, did that do it for you? Wait, let me try. We're going to try another one. Minus 1, 1, and minus 10. Okay, so if I'm going to do that, let's go and try to subtract. So I get minus 1 for A, and then minus 1, and then minus 10, which is plus 10. That's 8. I don't like this. What works? Somebody said, A is 10, B is 1, C is minus 1. Okay, let's try another one. So this one also no. This is not good. The next one is going to be, you said 10, 1, minus 1. Okay, 10, 1, minus 1. 10, 1, and minus 1, they don't multiply to 10. I can't do that, right? I can't do that with multiplying to 10, right? Because these things don't multiply. These multiply to minus 10. So in that case, what's the answer? So only one negative won't work, right? We're basically looking at what our options are, okay? If I try to do something with 5, 3, and 2, not 5, 3, and 2, it's like 5, 2, and 1. 5, 2, and 1, even if I use some negative stuff, doesn't work there. So I can't do it with 5, 2s, and 1, like a 5, a 2, and a 1. That's how you factorize 10. 5, 2, and 1, even if I put two negatives, I would still get the biggest thing to be 8. And then if I did it with 10, 1, and 1, 10, 1, and 1 also doesn't work. If you do 10, 1, and 1, I get 8. So now I'm actually thinking, is there no whole number solution? Well, there's no whole number solution. Oh, wait! What that means is I have to actually use the disgusting formula. Now I'm actually glad I did this. Oh my gosh, when I saw you guys typing in the 110 minus 1, I was like, 1 minus 1 minus 10, I was like, oh well, there's going to be some nice solution. But I don't think there's any solution with whole numbers, with integers. And so, but when I saw the chat, I was like, well, I know you guys have found some nice thing by guess and check. Let me show you a systematic way. And I know the systematic way will work, but it'll be disgusting. But actually, it looks like it's the only way now. I see some people suggested minus 1, minus 10, and minus 1. But that doesn't multiply to positive 10 either. So actually, that doesn't work. So now when I look at this thing, I say, I guess all I have to do is I just have to go and try all of these different possibilities. I see that Danny Lam is also emphasizing A bigger than B bigger than C. So we would have to check, whatever spat out of this. But it actually should work. The way you do it is you would go and just like choose lots of different choices for the C, throw it in and see what happens. I would just recommend not trying C equals 0. Because if you throw C equals 0, that's no fun. Okay. Well, I think that actually that answers the question. The question is called, just go and choose some C's, throw C's into this thing, you'll get values of X, and then from that value of X, go and calculate an A, which is 10 plus all of those. Oh, that's nice. Oh, A is 10 plus B plus C. So the way I would do this is I would actually choose a C, which is positive, and I would choose a B, which is also positive. I hope that's possible. Yes. That's actually possible. So the thing I was worried about at first was, oh, what if I fail this inequality? But I think it's possible. And here, oh, you know what? I see a way to simplify. Oh, no, I don't. I thought I saw a way to simplify this and I got all excited. But I don't, because I wanted to cancel out this C. And I can't, because I can only cancel off this C if there's a C squared throughout the underneath of this square root to factor out a normal C. But there isn't. So actually all I can do is I can say, pick a C, and then, which one do you think I want, the plus or the minus? If my goal is to make it so that A is bigger than B is bigger than C, I guess I would probably want to pick the plus, right? If I pick the plus, then I'm in good shape. I will actually make sure I got as big as possible. And the nature of this is that since this piece squares to be there, and I still added a bit more, this square root is still going to be more than what you're subtracting here. So I think what I'm saying is pick a C, any C, and as long as the C spits out a value of X using the plus sign, which is bigger than the C, it works. Okay? Well, so that finishes this question. It turns out it's disgusting. No offense to you, no offense to you, no offense to the question. It just turns out that we have to sometimes use all of these techniques. And I don't actually mind at all that we had a question of this form. I think it's very useful to see that there are some questions for which guess and check just won't work. Okay, more questions. Oh my gosh, this is so funny. Ethan Cao. Wow. So Ethan Cao has a question, and it says, Po the dolphin is texting his friends, Debbie and V4913 in class. Well, I mean, messaging his friends. When he uses messages, then he has a 30% chance of being caught. But when he uses Facebook, he has a 40% chance of being caught. And when he uses Instagram, he has an 80% chance of being caught. Is this what you guys actually do in school? Instagram. 80% chance of being caught. So this is apparently what everyone does in school. Everyone in school apparently texts all their friends with messages, Facebook and Instagram, and people try not to get caught. Is that what actually happens? I'm not sure, but we're saying that somehow this is what's happening. Apparently Instagram is very easy to get caught. I can understand why. It's because you can see the picture. Maybe. All right. Anyway, so we got all this, but the question says, what should he use to get a combination of 50%? So it's like, you got these 3 different ways of getting caught. How to split across, so that there's a 50% chance. Of being caught. Okay. You're saying go on Twitter to get 50%. It appears that you guys don't use Snapchat. I always had heard that people use Snapchat for everything. Is Snapchat dead or something? Do people only use Facebook now? Bo says Snapchat is 100%. Oh, okay. Oh, 0% chance to get caught with Snapchat. All right. So yeah. There's Twitter, there's Snapchat, there's WeChat. What else do you guys use these days? So actually, I'm now learning, right? So oh yeah, WhatsApp. How did you guys forget WhatsApp? TikTok. There's also TikTok. By the way, right now I'm learning what all of the different ones are. Apparently, people use Discord too. Okay. Yes. The thing that I find very interesting is, does anyone actually pass messages with paper anymore? Is that a thing? Does anyone actually write messages on paper and like pass the paper anymore? Or do people just like use phones? No? Nobody uses paper? Oh, this is great. Okay, anyway, this is very funny. All right, sometimes people use paper. Let's do this problem. So if you want to do this problem, how do you get 50%? Well, I guess you actually have many answers, okay? There are many answers because there are 2 things here which are pretty good at avoiding getting caught, Facebook and messages. And one thing here which is pretty lousy, Instagram. And now, because there's 2 different things I can use up here, I can actually use like more messages and less Facebook, or I can use more Facebook and less messages. Okay? And just to make this question easier to deal with, I think what I'll do is I'll just show you how to do it if you were just using Facebook and Instagram. And of course we can add more things. We can get more complicated. But just between these 2, because 50% is already in between them, I can already make a balance of these 2 so that there's a 50% chance of getting caught. And here's how to think of it. Facebook, 40% happens to be 50% minus 10%. Instagram happens to be 50% plus 30%. Now, why is this relevant? The reason this is relevant is because this is going to help you know, like, how much Facebook should you do for each Instagram. And then if you used each one once, by the way, if you used a Facebook and then an Instagram, what's your chance of being caught? Your chance of being caught will be exactly half of the sum of these. It will be the average of those 2, which should be 50 minus 10 and 50 plus 30. The average of 50 minus 10 and 50 plus 30. Does anyone know what's the average of these 2 numbers? It's 50 plus how much? What's the average of the green and the pink? It's 50% plus halfway in between minus 10 and plus 30. Minus 10 is minus 10, not plus 10. So if I have minus 10 and plus 30, their sum is 20, but my averaging makes me 10. So the average of these 2 is 50% plus 10%, which is 60%. Now, I wanted to know how to make it so it's just a plain 50%. So what you do is, if you want these things to balance out, for each Instagram you do, how many Facebooks should you do? Maybe you can see it. The reason I wrote it as 50 minus 10 and 50 plus 30 is so you can just see it. You can see that, look, for every Instagram, I'm going to pick up a chance of getting caught of 50% plus 30%. Should I do 4-to-1 ratio? Should I do 4 of the greens and 1 of the pinks? Well, think of it this way. Think of how much you're adding and subtracting. If you did a 4-to-1 ratio, it's like 4 times you get a minus 10, 1 time you get a plus 30. And that averages out to actually a minus 10 divided by 5. You did 5 times total. It's actually 3-to-1. Because you see, if I take 3 of the minus 10s, and then I take 1 of the plus 30s, they cancel. Does that make sense? Minus 10, minus 10, minus 10, and then plus a 30. So you got 0 in the end. So you should do this 3 times, and this 1 time. So that gives you an answer. The answer is, how do you get caught about 50% of the time? Well, what you do is you do 3 Facebooks and 1 Instagram, and 3 Facebooks and 1 Instagram, and 3 Facebooks and 1 Instagram, and so on. Or you could kind of intermix them, but as long as it's a 3-to-1 ratio, that's what you do. And now you see how I like to do this. I like to do it where you write like the thing you're looking for, the 50%, minus and plus. So it's very clear how many times you do the minus and how many times you do the plus. All right. I see that Sophie Huang is asking, why do you even want to be caught 50% of the time? I think what I'm impressed by is that somehow 80% is insane. I mean, to be able to be caught 80% of the time means that it's like really effective catching. 80% is a lot. All right, more questions. Oh, wow, wait. I saw somebody said all 3 once. Oh my gosh, you're right. All 3 once is beautiful. I like it, I like it, I like it. So you're saying that all 3 once would also be right, because this is 50 minus 20, this is 50 minus 10, and this is 50 plus 30. So when I average them together, all of them have 50, so I don't care about the 50. The average is 50% plus the average of minus 20, minus 10, plus 30. That's 0. So actually the best answer to this question is just do a message, a Facebook, an Instagram, a message, a Facebook, an Instagram, and so on. Nice. Thank you for sharing that comment. Okay. Somebody asked about Novid. I'm happy to answer. Jeffrey Kwan asked, how is Novid going? You know, I mean, I actually haven't talked as much about how Novid is going on this live stream for a while. It's going pretty well. If you go to the Novid website, you'll see that there's an article now on the Novid website talking about how it's really accurate. We were very proud to do a bunch of experiments to go and see exactly how well we can find the distance between 2 phones. And if you go and look at this, you find out that pretty good. And in fact, that makes Novid right now the world's most accurate contact tracing app that can sense the distance between 2 phones. And with that, we're now trying to help make this world a safer place as quickly as possible. We finally have gotten other people to notice that we exist, and we're getting people contact us now. How many downloads? We've had more than 40,000 downloads at this point. So thank you very much for your curiosity, but we are hoping to go and accelerate this even more because, again, I know that people watching this live stream come from all over the world, but I live in the United States. And right now in the United States, COVID-19 is becoming a very, 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 very big problem. So we are hoping that we will be fast enough to let as many people know that it exists to try to stop this before everyone gives up. Okay, more questions. Now we're doing like general questions, all right? So I'll take this one. GZA has asked, what are the most important math classes for programming? I've heard discrete math and linear algebra are essential. I agree. I think that discrete math teaches you how to think about networks, about graphs. It also lets you think about like how efficient your programs are, like how many different steps your program is taking. Linear algebra will help you do any kind of machine learning or artificial intelligence. But I'll also say there's another one that's useful, which is just like how to write proofs. So at the university where I teach, Carnegie Mellon University, all of the students in their first year in the computer science major take a class where they go and think about how to write not computer proofs, but write math proofs. And if you can go and reason about logic and mathematical proofs, then it becomes easier to write a computer program. Because a computer program is actually a logical proof. I mean, it's a bunch of steps that if you follow these steps, then the desired outcome comes out. Okay, more questions. I see that we have a question by Jayendra Jha, how to find passion. I think that the best is just to find something that you think is meaningful. I think that there's a question that you should ask yourself eventually, which is, you know, what would it mean for me to have been satisfied with what I've done if I looked back 10 years later, 20 years later, or at the end of my life? Like, what would I want to look back on? I think if you start to think about this question, you start to find out what drives you. And then once you find out what drives you, you go and try to figure out a way to answer that question. But Unfortunately, if you just kind of go through life just doing what you're supposed to do and never think about that part, then at the end you kind of wonder, what was all this for? I see that somebody else said you can just go to a store and buy passion fruits. But I think that here is a more serious question of like, how do you actually go and find out what you care about? You really have to think like, what would you think is meaningful? Like, why are you here? That's something for everyone to answer for themselves. I'm trying to see if there is any kind of a general question that I can use here to finish up. Okay, I see that somebody has asked, what is your favorite color? So I'll answer that one. And the way I'll answer that one is by kind of putting a color on the screen, and this will be kind of a fun way to finish up. I'll get big all of a sudden, right? So this color, this color of like sort of blue, sort of purple. Some people have called this blurple. Some people call this blue, but I like this color because somehow it's a blend between the blue and the purple, and nobody's quite sure which it is, and I actually quite like that. I think that when it happens to be halfway in between, then it's whatever you prefer, and that also happens to be the same color as is used in all of the things that I'm involved in making. Well, with that, I think I've turned giant, unfortunately, so that means that I should probably say also goodbye to everyone. Thank you to everyone for coming today. Hope that you had some fun in Ask Math Anything, and we'll be back again tomorrow at the same time. Take care.